All right, so it says find the area bounded by the graphs of x equals y squared and x equals 2 minus y squared by integrating with respect to y. Okay. All right, so this one we have x equals y squared. So what does that look like? Sideways parabola, right? You got it. And then x equals 2 minus y squared. So the minus means it would flip the other direction. And then the 2 means you'd go to the right 2 in this case. So it's going to look like this. Okay, so that's what we got going on. So we're trying to find the area in between. So first we need to figure out, well, I guess we don't need to figure this out. I was going to say these points here. But let's talk about it. So since they're already solved for x, so it's x equals y something and x equals y something, we want to try to integrate with respect to y. So that just means at the very end I'm going to have dy. All of my variables that I'm integrating are going to be y, and my limits of integration, so those are the numbers on your squiggle, those are going to be y values. Yeah?
It's exactly the same as regular numbers, just switched around.
Yep, we're going to do right minus left. So my right curve was 2 minus y squared, and my left curve was y squared. Okay, so now my y values are going to go from bottom to top. Okay, so we do actually need to find those points. So we need to find the point here and the point here. So how do we find what those 2 points are?
Set them equal to each
Yeah,
other.
set your 2 equations equal to each other. So you have x equals y squared and x equals 2 minus y squared. So we're going to say y squared equals 2 minus y squared. So I get 2y squared equals 2. So y squared equals 1. So it's happening at y equals plus or minus 1. Now you don't really need to find the x values that go with that. It's easy to find that x is just 1, right? It's at 1, 1, and 1, negative 1. I saw, so divide by 2.
Why did you divide by 2? There's 2y squared equals 2.
Yeah, before I can take the square root, I need to divide by the 2. So basically that point is 1, positive 1, and this point is 1, negative 1. And like I said, if you didn't know what the x value was, it's not really that important because you're just using your y's on your limits anyway. So your limits of integration are from negative 1 to 1, so the small one to the large one. All right, so now let's integrate. So I'm going to simplify first. So I have 2 minus y squared, so it's going to be 2 minus 2y squared dy, going from negative 1 to 1. So it's going to be 2y minus 2/3 y cubed, going from negative 1 to 1. Now, my drawing's not very good, but can you guys tell it's symmetric? It should be symmetric.
Yeah.
Right? You have a parabola intersecting another parabola. It's going to be very symmetric. So what you could actually do is you could say this is 2 times 2y minus 2/3 y, going from 0 to 1. Like you could break it up into 2 pieces. So the red and the blue piece. So see how it's just doubled out.
How did we do this?
Huh? Y cubed. Oh, y cubed. Thank you, Tina. All right, so the reason I would do that is because it's always easier when you have 0 for the second one. Because see, when you plug 0 in for the second one, it just cancels. So see how that makes it a little bit easier.
But we still could have used the other one.
Yeah, you could have used it. So when I plug in 1, I have 2 minus 2/3 with a 2 out front. Yeah. Yeah, that's what I'm saying. See how, look at my screen, see how this is red and the other part's blue? Those should be exactly equal. It's symmetric.
Yeah.
So you're just adding those 2 areas together. So you're going to get 2 of those pieces.
Okay.
All right, so I get 4 minus 4/3. So thanks.
Brian.
Okay. Find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6.
Oh, there's a lot of space here.
Yeah. Okay, the first one's easy to graph. It's y-intercept is negative 1 going up, like that. Second one, not so easy to graph. So I have y squared equals 2x plus 6. So it's going to be y equals plus or minus the square root of 2x plus 6. So you might want to see what that looks like on your calculator. So those are two functions. Plug one in for y1, one in for y2. So I'm going to do the square root of 2x plus 6. And that's going to be a parabola. So it looks like it goes through 3, which makes sense because if you plug 3 in, or negative 3, that's how you get 0, so negative 3.
What Kwame?
Yeah, Kwame, do you have a question?
Do we ever have to graph any of these things?
That one is not one that would be on the non-calculator one. But if you did, you could always do a t-table.
Always do.
The ones that were on the last example, so these, you should know how to graph x equals 2 minus y squared. It's just using those shifts that you used before. Go ahead and put the x minus 1 in for y3. Do you see the areas right here? So when I set it up, I'm going to have my right minus my left. So my right was x minus 1 minus my left. So notice I did something wrong. What's wrong? If I'm doing right minus left, I need
2 functions.
not 2 functions, but I need my y values, right?
Can't forget the y value.
Yeah.
How'd you forget the y value?
So we need y values. So this is going to be y squared minus 6 equals 2x. So it's y squared over 2 minus 3. Or 1/2 y squared minus 3 equals x. What about this one? This is just going to be x equals y plus 1. Okay, so my right is going to be y plus 1 minus my left, which is y squared over 2 minus 3. My left piece, so red is my left piece, green is my right piece. And now I can just do it all at once. Okay. Also, when you solved, so it was y, y equals something, you had 2 functions. You see this, Steve? You had plus or minus, you had 2 functions. So that already is telling you that you're going to have to break it into 2 integrals. Because you're going to have the first one with a top or bottom, the second one is a top or a bottom.
You could just use one.
Yeah, or just use one. Okay, so right minus left, so I have it set up. I am going from this y value to this y value. So this is real easy to do on your calculator. You could also just, you could try to set them equal to each other and solve, but since we already have them in for y1 and y2 and y3, let's find the intersect. Be careful, think about which curves you're intersecting. So I'm going to do the top 2 first. You can move up and down to go from each curve. Top one's 5, 4. What's the bottom one? It's kind of hard when you have 3, isn't it? They keep bouncing around.
You have to, how do you bounce?
You can move up and down to bounce from one curve to the other curve. So I'm going to go to the bottom parabola, and I'm going to use that as my first curve. And then my second curve, I need it to be the line, so trace along the line and hit enter,
I got
and then
5, 4.
guess. And then what did you guys get for the other one?
-1.
Yep. So -1, -2. All right, so that means my y values are from -2 to 4. So if you're integrating with respect to y, so I have dy, I have y's in my integral sign, and I have my y's for my limits of integration. Yeah, Tina.
Like you're going from right to left, right? But like when you're -1, -2 isn't like your most left point. Like how would that be the area?
Okay. When you're going from right to left here, these are going from bottom to top. And when you're going from top minus bottom, those were x values, so those were going from left to right. Okay. Does that make sense? Okay, good question. Okay, so we're going to integrate. So I have -2 to 4 of y. I'm going to have 1 minus a -3, so 1 plus 3, so 4. And then I have a minus y squared over 2. I didn't write it in order, but that's okay. Okay, so when I integrate, I get y squared over 2 plus 4y minus, it's going to be y cubed. So what am I going to need out front? Good, 1/6. 1/6. Going from -2 to 4. All right, this one's not very nice. We can't just break it into two pieces, two equal pieces. We actually need to find it. Okay, so when I plug in 4, I get 16/2, so 8 plus 16 plus 4 cubed is 64, so I need minus 64/6. So for my first number, I get 40/3. And then minus, so when I plug in -2, I get -2 squared is 4/2, so 2 minus 8. And then -2 cubed is -8, so times a -1/6. So it's 8/6, or 4/3. So I get minus a -14/3. 18. Okay, so you get 18 for your answer. Okay, so the birth rate of population B of t is 2,200 plus 52.3 t plus 0.74 t squared people per year, and the death rate is 1460 plus 28.8 t people per year. Find the area between these curves, between 0 and 10. What does this area represent? Okay, so let's sketch it out. So go ahead and put those into your calculator as your y1 and your y2. Okay. When you adjust your window, look at your B of t. See how that's a 2200 for your constant? Usually that kind of gives you a clue that it's going to be really high up. So I would maybe change your window so that the y max goes to like 2500. And then your x max, let's make it go to 20. Because we're just going between 0 and 10 years. Does that give us it? Let's go a little higher. So let's go to 3000. Okay, so what I have on my screen is something like that. So this is my D of t. This is my B of t. So I'm finding the area between 0 and 10. Okay. So since those are already in as your y1 and your y2, we're going to set it up on our calculator. Like, here's what the calculator will say. It's going to say fn int, so your definite integral. This was our y1. That was my y1 at least. You might have them flipped. Minus y2. And my x values, so that was top minus bottom. So I'm going to say x goes from 0 to 10. So hit math 9. You're going to hit variables and arrow over to y variables. So y1 minus variables, arrow over to y variables, y2, going from 0 to 10. Are you guys trying this along with me?
What'd you get?
What'd you get?
8,820.
Yep. Oh, you guys get that? All right, so what does this represent? Yeah. So did you guys see what Ayush said? He said net increase in population. So you have a certain number of people being born, but not as many people that are dying each year. So that's how much the population is increasing each year. So by 8,000 people. That's a lot of people. So we're going to say increased by approximately 8,822 people. We'll count that as 2. Remember, on your AP test, you get a point sometimes for just having the correct units. All right, so I gave you a little note at the bottom. It says when integrating with respect to x, you should have dx and x values for your integrals. It should be top curve minus bottom curve. With respect to y, you're going to have y values that you're integrating, and it should be right minus left. Okay? Okay, let's go ahead and talk about volume a little bit. Do you guys feel pretty good about those?